Digits of 2024 have the property that 7 squared plus 7 to the 0 plus 7 squared plus 7 to the 4 is 2500, which ends in two zeros. Find how many sets of solutions there are for single digits A, B, C, and D. So that's the digits from 0 to 9. Very important to include the 0 as they've done in the example, so that this summation also ends in two zeros. Note that if you change the order, then we get two different sets of solutions. So let's write down our powers of 7 using two digits. 7 to the 0 is 1, so it's 0, 1. 7 to the 1 is then 0, 7. 7 squared, 49. 7 cubed, well, 7 times 50 is 350. Minus the 7 gives 343. But I'm really interested in the last two digits, so 43. And 7 to the 4, I don't need to think about the 300 because when I times that by 7, I'll just be in the hundreds and the thousands. So 7 to the 4, the last two digits are going to be 7 times 43. That's going to be 280 plus 21. That's 301. So it's going to get back to 0, 1. And then it must repeat. So we can write all the rest down quickly. Technically, we are using modular arithmetic here, so I could write down mod 100. Sorry, that's what we're left with when we divide our answer by 100. Okay, but don't worry too much about that if you've never seen that before. We're focusing on the last two digits, but that is how you can write them. Now let's think about how we can add these together to get 100. Well, if we used two 49s, then I'd have to use two 1s. That would work. If I used a 49 and a 43, I'd have to use a 7 and a 1. Or we could use two 43s and then a 7 and a 7. And that is it. That's the only way that we can use these last two digits to get to 100. But of course, there's quite a few ways because we could use the 7 squared here, or we could use the 7 to the 5 and so on. So we need to kind of consider each of these separately. I'm going to do 1, 2, 3, but then let's work out the number. It's now all about the arrangements within this. So for 49, 49, 1, 1, I need to first of all think about how I could swap these around. So I could swap these two around, for example. There's a really quick way to work out the number of permutations. There are 4 factorial ways to arrange for different objects. But now if I swap the 49 and the 49, it wouldn't change it. So I can divide by 2, or in general 2 factorial, because if there were 3 things, it would be 3 factorial. And then I can also swap the 1s around. So I divide by 2 factorial times 2 factorial. 4 factorial is just 4 times 3 times 2 times 1, and then dividing by 4. So there's actually 6 ways to arrange that 49, 49, 1, 1. If you're not so familiar on factorial notation, that doesn't stop you doing this question. You could just write them all down. So we could write down the 49s first. Then we could maybe put them, put them second and third next to each other. And I could put them last. Okay, that's all the ways that they're next to each other. Then I could maybe keep the first one here and then separate them by 1. So then I could do 149, 149. That's all the ways when they're separated by 1, which just leaves us the situation where they're separated by 2. And I systematically worked out them all, those 6 possibilities. I'm going to get rid of that. But that is how you could do it without the factorial notation. But I'd say look into this. If you're doing Olympiad problems, then get to grips with arrangements, and then you'll be away with this sort of question, but you can do it more quickly. Okay, so we've got 6 ways that we can arrange it, but now we just need to think about one extra little bit. So I'm going to be doing 6 times, and now I need to think about how many different powers of 7 could end in 49. And let me circle it in purple. So one, there's just two options there. So there's two options for the first 49. And then there's still two options for the second 49 because I can reuse it. I can use the same one twice. Like I can use 7 squared and 7 squared. And then for the 1, there's actually one, two, three options. So I'm going to be times them by 3 twice. Because essentially, let's say I just have 49, 49, 1, 1. So I could go, I've got two options for how I get the 49, either the 7 squared or the 7 to the 6, and then two options for the second one, that one is second, and then three options for the 1 and three options for the 1. But within that, after I picked it, I can then rearrange it in 6 ways. That's why I have to multiply them all together. Just going to leave it like that for the moment. We'll come back to it. I'm actually going to do number 3 next because it's exactly this. Is it the same result? Well, nearly. I've got still the 6 from arranging them. Okay, but now how many 43s have I got? Well, I've got 2. I've got 2 times 2. And yes, it is the same because I've also got 3 7s. So 3 times 3. Okay, I went through that one a little bit more quickly, but it is exactly the same idea as number 1. That just leaves us number 2. So now I've actually got 24 ways I can arrange it. It's 4 factorial. There's 4 ways I can pick the first one, then 3, then 2, then 1. There's no repeats. But now I'm going to need to think about how many 49s there are. Well, I've got my 2 options. Then the number of 43s is 2 as well. Number of 7s is 1, 2, 3. And then there are also 3 1s. Okay. That actually turns out to be 4 lots of 6 times 2 times 2 times 3 times 3. So if I've got 1 lot and 2 lots and then 4 lots, then the total is going to be 6 lots. It's almost, let me put this in brackets. So this is in a bracket now. Yeah, that's like my x, and I've got 4x, so it's 6x. So it's 6. I mean, there's different ways you can do this. 6 times 6 times 2 times 2 times 3 times 3. Okay, how best to sort it out? I guess I could do 2 times 3 is 6. 2 times 3 is 6. It's actually going to become 6 to the power of 4. Well, that should be like an absolutely fine answer, to be honest. But I'm going to work it out as a full like answer, not in powers form. So it's going to be 36 times 36 because it's 6 squared times 6 squared. 6 times 6, 36, and 18. That's going to give me 216. That's 36 times 6. 0, 8, 9, 6, 9, 2, 1. Okay, that is the total number of ways. Nice question. Well done.